Next title is the benefit of nuclear power plant introduction in Japan. We have two presenters. First is the Mr. Takuya HATTORI from JAIF. Hattori-san, please.
Thank you. Thank you, Mr. Kishida. Good afternoon, everybody. My name is Takuya HATTORI, advisor of JAIF, JAIF. It's my great honor to make presentation in this seminar. The title of my presentation is The Benefits of Nuclear Power Plants Introduction in Japan, focusing on national level. Another speaker from Mr. Yamamoto, he's mainly talking about for the local level. Today, I'd like to talk about today's topic in relation to the history of nuclear development in Japan, and also based on my experience. I hope my presentation will be informative for you to launch the nuclear program in your country. Prior to start my presentation, let me introduce myself as shown in this slide. I was born in 1944, before World War II over. Though I have already reached the retirement age, I'm still working for the sustainable development of nuclear power in the fields of international cooperation and human resource development based on my 50 years of working experience in nuclear industry. My presentation consists of 5 items as shown on this slide. Please look at this one. You can see the pictures on the right side show the difference between before and after development of nuclear power station. Upper picture is the desolate dune of Alhama district of Kariwa village in Niigata Prefecture of Japan in 1950s, before development. Lower picture is the TEPCO's Kashiwadaki Kariwa nuclear power station. Total site area is 4.2 square kilometers. After completion of 7 units construction in late 1990s, total capacity is more than 8 gigawatt. This slide shows the key factors of Japan at a glance as of 2020. Japan is located at the far east end of Asia, almost 8,000 kilometers away from here. So, I'm not sure how familiar about Japan for the people of Estonia. Located far east Asia and close to the Korean Peninsula and China and Russia. Very sensitive area. It lies on plate boundary in the volcanic belt and quake-prone area. We experience almost every day earthquake. Consists of 4 major islands and mountainous countries, almost 70% of mountain. A densely populated and technology-oriented and highly industrialized country. And now the decreasing birth rate and aging population is a very serious social problem. And now is about 200,000 or 300,000 per year decreasing the population. This slide shows the unique status of energy situation of Japan. And as shown on this slide, the highest priority of Japan energy policy is to secure energy supply assurance. That because highly industrial countries, as shown, as mentioned, and a high energy consuming country, and no indigenous natural energy sources, no coal, no oil, and no gas. One of the largest LNG import country in the world, and energy self-sufficiency is 12.1%, in 2019. This is the lowest level of the OECD countries. And last is we have no pipeline and electricity network, electricity grid and no pipeline network with neighboring countries. We are a very isolated country, physically very isolated. Next is change of generation power capacity in Japan. This slide shows the historical power demand increase to cope with the high growth of Japanese economy. From 1955, 10 years after World War II overcoming the post-war turmoil, Japan started on the road of recovery. Average economic growth rate between 1956 to 73 is 9.1%. It's very high compared with the current level. And as a result, GDP of Japan in 1975 reached 5 times of higher than that of 1955. As shown here, this is the GDP, 5 times. To cope with this high energy demand growth rate during these 20 years, power generation capacity, gigawatt, and generated power, terawatt hour, increased 8 times and 7 times as shown on this slide. This slide shows the change of energy mix of power generation in Japan. In 1955, primary energy source is hydropower, and secondary is coal, and gradually changing to primary thermal and secondary hydro by 1965. In 1973 and 1979, so-called oil crisis happened, and Japan decided less dependency on oil from Middle East as energy policy direction. Nuclear, LNG, and coal were actively developed by pursuing the best mix. And from late 1990s, global warming issue coming out as a new and common challenge in the world. As a result, energy mix of power generation in 2010 had reached to nuclear 28.6, LNG 29.3, coal 25, oil and others 7.5, and hydro is 9.7. I think this figure might be one of the best energy mix of Japan at that time. This introduction aside, I would like to move the first topic of nuclear power development of Japan. This slide shows the quick overview of the history of the nuclear development in Japan. Japan started to study about nuclear energy after the famous US President Eisenhower's speech, Atoms for Peace in United Nations in 1953. In December 1955, Atomic Energy Basic Act of Japan was enacted in the Diet, and the related legislation was established thereafter. And Japan officially started nuclear power development program in collaboration with government, industry, and academia. That is very important. Collaboration, government, industry, and academia. It's very amazing. This is 1955 is 10 years after the disaster of the atomic bomb in Hiroshima and Nagasaki in 1945. It's very amazing. Japanese, the general public, accept to officially started the nuclear. This slide shows schematic overview of the history, focusing the number of the nuclear power units every 10 years since 1960 to 2010. You can understand that Japan has steady and smoothly developed nuclear power within short periods of time. and severe nuclear accident happened at TMI and Chernobyl did not affect so much to the nuclear development program in Japan. Here, I'd like to stress the following 2 points of characteristic in the nuclear power development in Japan. This is shown in the bottom side. The first is a continuous construction of 57 nuclear power plants without interruption. This is a very rare case in the world. And the second is average construction period of 57 nuclear power plants is 48 months. This is very short compared with other countries. I'd like to show the next slide by the comparison. As I mentioned in the previous slide, construction period of the nuclear power plants in Japan is relatively shorter than that of other countries. This slide shows the comparison of construction period of major nuclear countries in the past based on the database of IAEA. Because of the time constraint, I don't explain in detail today, but I may have a chance in the future. I'll talk about that, why Japan is shorter than other countries, if you are interested in this matter. In addition to the previous slide, construction periods of nuclear power plants in Japan. In addition to the previous slide, I'd like to show another data of the construction period of Generation 3 and 3+ reactors, which started operation recently. As you might know, the most important challenge and risk of the new reactor construction is to prevent cost overrun by delay of construction schedule. Until now, the number of reactors of each type of Generation 3 or 3+ is limited, as shown in this slide. However, we have to realize this reality, and world nuclear community have to continue to make efforts to shorten construction periods as much as possible. Very unfortunately, the AP1000, EPR, Hualong, and ACPR and APR1000, VVR, is all 4 to 5, such as a very limited number, but the very long period of time. But in the case of ABWR in Japan, is the 43 is amazing for them. The reason why, I can show this, but today I don't talking about that. This slide shows the process of establishment of the indigenous nuclear technology in Japan and the strong support of the government and close collaboration with government, industry, and academia. Initially, nuclear technology were imported from nuclear developed countries like UK and the United States. And then these technologies were customized, improved, and transformed as indigenous technologies through Japanese operation and maintenance practice. I don't talk this in detail, but anyways, if you have any questions after that. This slide shows the main activities of relevant stakeholders, that is government, industry, and research institute. I'm sorry, this slide is a little bit busy, and you can see it, you can't see it. But what I'd like to stress to convey to you is collaboration between stakeholders is crucial for steady development of nuclear power. Collaboration. Next slide. This slide shows the general trends of nuclear development in Japan during each decade since 1960 to 2019. And the name of each decade is my personal view. And looking back the past 60 years, historical trends of nuclear development in Japan. Number of each column shows the number of units which started construction, commercial operation, and shut down in each decade. You can see the trends. very unfortunately for the 2010, for the Fukushima accident happened, and many shut down reactors. And in this period, it's very rapidly growth in the Japanese nuclear program. From now on, I'd like to move to the second topic of economic benefit from industrial introduction of nuclear power. This figure shows what kind of impact is expected by introduction of nuclear power. As shown in this slide, introduction of nuclear power is the driving force of economic growth and job creation and turns a positive the cycle of economy. As I mentioned, generating power is in economic growth, is power demand increase, and utility companies invest, and this will for the sales demand amount is going up, and R&Ds started, and also nuclear power is keeping safety is the highest priority. So quality management capabilities is crucial, promoting education and training of young engineers and workers, generate qualified personnel for improvement of technical capabilities. This movement is also expected to produce spillover effect to new fields of industry. And as shown in this page is related to the page I will talk afterwards. This slide shows the transition of the nuclear power capacity in Japan. You can see how quickly nuclear capacity increased from 1970 to 1980. The green graph is how rapidly increasing the capacity. Next slide, this slide shows the transition of the nuclear power generation terawatt hour in Japan. You can see the increased rate of the power generation is higher than that of capacity because nuclear power units with larger capacity were introduced by electric power companies considering the economy of scale. After introduction, we consider about for the economy of scale. First, it's very risky. After customize or after that, we have to consider. First, conservative way you have to. That is a very, very important point. This slide shows the change of the nuclear-related cost of electric power companies, as shown in this slide. Nuclear-related cost increased in proportion to the number of nuclear units under construction and operation. This slide shows the change of the nuclear-related sales amount of Japanese fabricators and construction companies. You can see the trends in the slide figure directly reflect the cost of electric power companies. That means the money flowing to the utility company, to the manufacturer and construction companies. In this process, nuclear-related companies in Japan has established their own indigenous nuclear technology. This slide shows the spillover effect of the nuclear power to other fields. It's a questionnaire result from more than 200 companies of JAIF membership gathered in 1980. It's a very old data. But the year of 1980 was 10 years after first-generation nuclear power plants started operation in Japan, and the nuclear-related companies in Japan were just started for achieving high level of maturity in nuclear business. So I suppose their feedback on the questionnaire might be a good reference to evaluate spillover effect of nuclear power from the current point of view. Each item is that is a 1980s timing. Now the robot, at that time the robot is not so popular, and the computer is just started the computer, yeah. And the seismic, the materials, the construction, these are very same as at present time. And measurement and control, this is very much for the improved. And since that time, and welding is the same. This is a very basic technology. And quality assurance is almost same at that time. This slide shows the change of the number of nuclear-related employees in the power companies and fabricators. You can see the number of employees sharply increased from 1970 to 1980. This 1970 to 1980, this is a time for the rapid growth of the Japanese nuclear program. The ratio of local workers at construction site is different from each construction site, but it can be said that about 2/3 in the case of utility companies and 1/3 in the case of reactor vendors. It depends on each company's for the policies, but many portion is the local workers working in the construction site. This slide shows the change of the nuclear-related R&D expenses. The figure in early stage from 1970 to 1980 is relatively high because we encountered several initial troubles for safe and steady operation to be overcome. These troubles were not so serious, but huge amount of money invested for root cause analysis to prevent recurrence of similar troubles. Because preventive maintenance, PM, preventive maintenance, is the basic principle in Japan. This is very different from maybe other countries. Corrective maintenance or preventive maintenance. In the case, we choose the preventive maintenance. This is very important for getting the trust of the local community to prevent any very minor troubles. From this page, I would like to talk about the final topic of key features in steady and sustainable development of nuclear power. This slide shows the life cycle of the nuclear power plant. As shown, as you might well know, it lasts almost 100 years from planning of nuclear program to finishing decommissioning work. And the initial phase of the life cycle, as described and as defined and described in IAEA milestone document, is the most crucial period of time. The factors listed here, this slide, is a prerequisite to steady and sustainable development of nuclear power. This is my personal view based on my 50 years working experience in nuclear field in Japan. First is a collaboration with relevant organizations. The second is the trust and confidence of local communities. And the third is human resource development. This slide shows the wide variety of the stakeholders of nuclear power plant construction project. I suppose it might be different from country by country, reflecting socio-political and cultural background, but it's clear that without mutual trust and collaboration between stakeholders, no project can succeed. As shown on this slide, in January this year, IAEA issued a special report titled Stakeholder Engagement in Nuclear Programs. And this might be a good reference for you on this matter. This slide shows the 4 key players in nuclear power plant construction out of many stakeholders. Number 1 is the owner-operator of nuclear power plants. Owner-operator was the primary responsibility on the safe operation of nuclear power plant. So, establishing integral management structure, allocating necessary budget and human resources, and responsible development should be guaranteed by owner-operators of nuclear power plants. Number 2 is the central government to promote introduction of the nuclear technology. The stability of the policy is very important, government policy. Very fortunately, Japanese government policy is very stable to promote nuclear power. Number 3 is a regulatory body. This is we are already talking about, who is an independent organization to assess safety of the nuclear power plant. And lastly, number 4 is, I can say, the most important player, general public and the local community near the construction site. For the success of the project, it is indispensable for these 4 players to respect each other, communicate openly, keeping the high level of transparency, and establishing trust and confidence between them. This slide shows the way how we can build trust and confidence with local communities. Here, I listed up 6 factors based on my experience, and I can say sharing the common understanding of nuclear development as described in the column. So, co-creating unique value with local community, and we have to recognize that it takes only one instance to lose all the trust, which you worked so hard to build over the long period of time. It's very easy to lose, but to construct, it takes time. Finally, I would like to touch on the capacity building for development of nuclear power. This slide shows that Japan's promote capacity building in nuclear technology during the initial development phase from 1955 to 1970. These 15 years, I can divide 3 phases of preparation phase, learning phase, and deployment phase, and major activities during each phase as shown on this slide. I don't speak in detail. This slide shows the key players who promote capacity building in nuclear technology during the initial development phase from 1955 to 70. As shown in this slide, government, utility company, reactor vendors, research institute, and university share the role and the responsibility in the process of capacity building. This slide is my personal view based on my experience and shows the necessary conditions for young engineers working in nuclear fields. As mentioned in my personal introduction, my major concern now is international cooperation and human resource development of nuclear fuels for sustainable development of nuclear technology. I understand my role is to transfer my experience to next generation. Because of my time constraint, I don't explain item by item, but please refer for your reference. This slide shows the expectation to the government role on human resource development. This is also my personal view on this matter. As written in this page, I can say that human resource is the most important asset to assure prosperity of the country, and human resource development is a cornerstone for sustainable development of nuclear power. This is the conclusion of my presentation. Each item summarizes the contents of my presentation. The first line, the nuclear power is clean, safe, reliable, and affordable energy source. And the nuclear power plays an essential role in clean energy transition within marginal cost. Nuclear power program developed into a long-term relationship between stakeholders. Collaboration between stakeholders is crucial in nuclear development program. Government role is vital for launching nuclear development program. Trust and confidence of local community is indispensable for nuclear power development. Development of nuclear power greatly contribute to the economic growth. Human resource development is a cornerstone for sustainable development of nuclear power. This is the end of my presentation. Before closing my presentation, I would like to send a last message to all of you. There is no silver bullet to realize a low-carbon society, but there will be no solution without nuclear. Thank you for your attention. I'd like to invite any question from the floor. Thank you.
Thanks so much. Could you please, I wanted to do the secure question time after the Yamamoto-san presentation. Okay. Anyway, thank you so much, Hattori-san.